So physics problem number 53. Two objects A and B are moving towards each other with velocities. So velocity of A is equal to 10 meter per second and the velocity of B is equal to 12 meter per second. Given that both the objects, this is A and this is B, both are moving towards each other. A is moving with 10 meter per second and B is moving with 12 meter per second towards each other. In that situation, the velocity of A with respect to B, velocity of A with respect to B is given by VA plus VB, which is equal to 10 plus 12, which is 22 meter per second. This is the concept coming under relative velocity. If both the objects are approaching each other, then we need to do VA plus VB. If both the objects are moving away from each other, then we need to use a VA from VA minus VB. VA minus VB opposite when they are moving opposite to each other and they are towards each other. Moving away from each other. In that case, we use this formula. So this is about 53rd problem. Next problem. Motion in a straight line, first problem. Motion in a straight line, first problem. Exercise 4. Exercise 4, first problem. In an experiment on the takeoff performance of an aeroplane, acceleration varies with time as shown in the figure. So they have given a figure which is like this. By taking time on x-axis and acceleration on y-axis. So this is 12 seconds, 6 seconds, 0 and 5 meter per second square. So acceleration is measured in meter per second square. Time is measured in seconds. This is the diagram given. So they are asking us to find out the distance along the runway covered by the aeroplane. So this is a very complicated problem. So observe this one. For time t is equal to 0 to 6 seconds. 0 to 6 seconds. Acceleration is equal to slope, which is y minus 1 y1 by x minus x1, which is equal to 5 minus 0 by 6 minus 0. The acceleration is equal to 5 by 6 into t, meter per second square. Let this be equation 1. We know acceleration is equal to dv by dt, which is equal to 5 by 6 into t. That implies that dv is equal to 5 by 6 t into dt. So now integrating on both sides, we get integral 15 to v into integral 6 to t. By applying this, we get v 15v is equal to 5t 6t. That implies v minus 15 is equal to 5 into t minus 6. V is equal to 5t minus 15. So this is of the form y is equal to mx plus c, which is the equation of a straight line. So Nitesh, note down up to here. After that, I'll continue the problem. Same problem I'm going to continue. For t is equal to 0 to 6 seconds, we have v is equal to 5 by 12 into t square. This is the velocity time graph. This is a vt graph, which will be a parabola passing through origin. So for time t is equal to 6 seconds to 12 seconds, v minus 5t minus 15 at t is equal to 12 seconds, v into v is equal to 5 into 12 minus 15, which is 45 meter per second. This represents vt graph of complete motion. Vt graph of complete motion. So still we need to continue this problem. So let us take now position time. Which will be position and time relation. From t is equal to 0 to t seconds. We have v is equal to dx by dt, which is equal to 5 by 12 t square. So that means 5 by 12 t square is equal to dx by dt, which implies 5 by 12 into integral t square into dt. So now integrating on both sides, integrating on both sides, we get integral 0 to x dx is equal to 5 by 12 into integral 0 to t square into dt. So which implies x minus 0 is equal to 5 by 12 into t cube by 3 to the limits 0 to t. That implies x equal to 5 by 36 into t cube. Now position from 0 to 6 seconds. Position or distance traveled. From 0 to 6 seconds. So x t is equal to 6 seconds is equal to 5 by 36 into 6 cube, which is equal to 30 meters. So from t is equal to 6 seconds to 12 seconds, we have v is equal to 5t minus 15. That implies that dx by dt is equal to 5t minus 5. So dx equal to 5t minus 15. 5t minus 15 into dt. Still the problem is there. Continuation. So now integrating on both sides. We get integral 30 x dx equal to integral 6 t 5t minus 15 into dt. That will be x 30 x equal to 5 into integral 0 to t dt minus 15 into integral 0 to t dt. So x minus 30 is equal to 5 into t square by 2, 6 to t minus 15, 6 t. X minus 30 is equal to 5 by 2 into t square minus 6 square minus 15 into t minus 6. X equal to 5 by 2 t square 15t plus 30. At t equal to 12 seconds, x t is equal to 12 seconds, which is equal to 5 by 2 into 12 square minus 15 into 12 plus 30. When you simplify, you get 210 meters. Exercise 4, second problem. They have given the graph like this. Here they have taken displacement on x-axis and velocity meter per second on y-axis, and an inclination angle of 30 degrees was given. This is the origin. Now they are asking us to find out the acceleration of the particle when speed is 0. So speed is equal to 0. They are asking us to find out the acceleration. So we know acceleration A is equal to V into dv by ds. If V is equal to 0, that implies acceleration also will be equal to 0. So we have option C is 0 meter per second square. It must be 0 meter per second square. Okay, next one. Bullet moving with the third problem. Bullet moving with speed 150 meter per second strikes a tree, penetrates 3.5 centimeters, which is equal to 3.5 into 10 power minus 2 meter. In this case, they are asking us to find out the magnitude of the acceleration and time. So they are asking us to find the acceleration as well as the time. So let us use this formula. After bullet striking the tree, it comes to rest. So this is initial velocity, u is equal to 150 meter, v is equal to 0. So we have the solution, v square minus u square is equal to 2as. Here v is 0, so minus u square is equal to 2as. So u square is equal to minus 2as, which is equal to, what is the u? 150. 150 whole square is equal to minus 2 into a into s is how much? 3 into 10 power minus 2. Here we get a is equal to minus 3.214 into 10 power 5 meter per second square. We know v is equal to u plus at. A is equal to v minus u by t. T is equal to v minus u by a, which is equal to 0 minus of minus 3.214 into 10 power 5. Oh no, no. Velocity u is 150 meter per second. 150 minus 150 divided by minus 3.214 into 10 power 5. This minus and minus will get cancelled. So finally we'll get the time around 4.67 into 10 power minus 4 seconds. This is the solution for the third problem. Next, fourth problem. The body starts from rest with uniform acceleration. Its velocity after 2n seconds is the displacement of the body in the last n seconds is. The two details they are asking. Body starts from rest, so initial velocity equal to 0. Its velocity after time t is equal to 2n seconds. V is equal to V naught. In this situation, they are asking us to find the displacement. S value they are asking us to find. So we have V is equal to U plus AT. U is equal to 0. So substituting all the details, we have V naught is equal to 0 plus A into time is 2n seconds. So 2n. So V naught is equal to 2an. And A is equal to V naught by 2n. Let this be equation 1. So for displacement in last n seconds, I'm taking t is equal to 2 seconds. So we have s is equal to v naught t minus at square, half at square. So s is equal to v naught into n. T is 2n. 2n minus acceleration is v naught by 2n. So v naught by 2n into t square by 2. By simplifying this one, we get s is equal to 3 v naught into n by 4. This is about the solution for the fourth problem. Okay, that's all for today.